Okay, so moving forward, we're still looking at polynomials and there's zeros, but we're going into complex numbers or imaginary numbers. And so we need to talk about this thing called a conjugate pair. And so let's do a quick little review of what imaginary numbers or complex numbers look like. So complex numbers come in the format of a plus bi. So some ways that we've seen complex numbers is that, maybe it was like 0 minus 3i, which really is the same exact thing as us just saying negative 3i. Then we can put the real number portion on there and say like 2, so 2 plus 2i, or negative 3 minus 4i. And I'm trying to do this quick review because this is not something that you've worked with a ton. We've done a few problems here, so you might have touched on this in high school some, or maybe briefly in another class, but this is really your first time in college algebra. We're going to be focusing on, or touching on, imaginary numbers. So now from here, let's go over and talk about what a conjugate is. Okay, so let's break this down and kind of make it as like a chart. So a conjugate, I don't want to go as far as say that a conjugate is like an opposite, okay? But in this case right here, negative 2 does not have a conjugate, so there's none. And the reason is because conjugates only happen when you're in the complex number system. So negative 2 is a real number. So since that's a real number, there's no conjugate. However, negative 3i is a complex number. And since it's a complex number, it does have a conjugate, and the conjugate is just as easy as that. If this is negative, then the conjugate is positive. All right, 2 plus 4i. In that case right there, it is a complex number. So that means it has a conjugate. So the real number portion stays the same. Then it goes from being a plus to a minus or a negative 4i. And those are our conjugates. So now let's go back and readdress what the question says. The question says, I want you to give me a polynomial of degree 5. I want you to find all the zeros if this polynomial is degree 5. Well, here's 1, here's 2, here's 3, here's 4, and here's 5. So essentially what happened is that I gave you 3 zeros, 1, 2, 3, and from those 3 zeros, you were able to use the whole idea of the conjugate theorem, the conjugate pairs theorem, to be able to find the conjugates of the complex to find your remaining zeros. So negative 2, negative 3i, positive 3i, 2 plus 4i, and 2 minus 4i gives us our 5 zeros that we needed to be able to make up this 5th degree function. Now let's carry that over one more time and practice that with one where I give you some zeros to ask you to find the rest. Okay, so same concept. I'm looking for a 4th degree function. My zeros are x equals 1, x equals 1, and x equals 4 plus I. So from here, we're looking for the 4th one. So we know that our first guy is a real number, no conjugate. Second one, real number, no conjugate. Third one, complex number, so it has a conjugate, and we basically flip that imaginary portion. So those would be our zeros, and so I just want to extend, that's what the question's asking, is find the other one, and we found it. But let's just, for conversation purposes and to expand this conversation, let's remind ourselves when we put these as factors. So this becomes x minus 1. This becomes x minus 1. This becomes x minus, and I'm going to change colors and put this in parentheses. Okay? And then the next one becomes x minus 4 minus I. So just kind of wanted to put that out there to kind of look at it. Obviously, we could simplify this a little bit, and this could really become x minus 4, right, if we distribute that negative sign through. So x minus 4 minus I. I know that looks weird, but that's the deal. I mean, so like, actually, let's do this. Let's just write that in red. So minus 4 minus I. Remember, that's a complex number. That's what a complex number looks like. I know we're used to seeing x minus 1. There's only one thing right here. But in this case here, it's 2. It's minus 4 minus I, or negative 4 minus I. This guy right here, when we distribute that negative through, that would be x minus 4 plus I. Okay, so our complex number piece coming in there. So just kind of keep that in mind. Hopefully that helps kind of build the concept, and so you can kind of just be exposed to it as we move forward. And that kind of wraps up conjugate pairs. The next video will actually use them to be able to find the actual solutions.